Okay. I think we finally got to the point where we're just going to go and hit x86 assembly a lot. We'll see how far we get today, which I can tell is not going to be that far, and that's okay. But we did do a little x86 assembly, and I'm going to go over actually a different set of slides, which I found recently that are going to be a lot better, as you can already tell by the title, Assembly, Architecture, Applications, and Alliteration. Hope you start laughing because it's going to keep going. So I updated these slides, and I took them from Zenokova. Approved for public release and distribution unlimited, because they actually attached a license to the slides. Look at that. It's the Creative Commons share-alike license. So I'm allowed to share, or I'm free to, and I'm free to remix and adapt the work as long as I attribute the work in a manner specified by the author, aka I put his name up front. And if you alter or share it, I keep putting their name up there. Or I can only use this license, sorry. All right, that sounds great. So there. You see how easy that was? Now I have not plagiarized. And apparently these people up here, whose names you will all memorize, helped as well. So these slides are taken from a class. I forgot to update this slide, but this is a x86 introductory class for security people. So this is actually, this is actually going to be pretty useful for cybersecurity. There are many times, or not many times, there's definitely a branch of cybersecurity where learning this stuff will be immensely helpful. All right. Point here is to expose you to the most frequently used instructions for an architecture. So they're going to stick with 32-bit instructions, which is fine. They're going to talk about how you implement a stack. Hopefully you remember that from, you had to take OOP, right? Okay, and she talked about the static stack. Excellent. So we're going to talk about the stack. We're going to go through some common tools. Hopefully, I'll get to IDA. Not IDA Pro, because that costs money, but probably IDA, the educational thing, which will be used for helping us actually analyze assembly. Some things will be left out. Well, sure, they will. Floating point, or 64-bit, or complicated or rare 32, and maybe some virtualization and cache hierarchy. I may add some of those. I may not. About the class part 2, I hope that this material cover will provide the required background to delve deeper in areas in which may have seemed daunting previously. And then this whole thing right here, basically saying if you have a question, please ask. And then, so the agenda, which I thought I edited this, but apparently I didn't. We'll talk about architecture. We're not going to talk about Windows tooling, because that's silly. And then we'll learn some more instructions, and I think we'll talk about inline assembly and some other assembly as well. The inline assembly is going to probably be closer to what you're going to experience if you ever have to deal with this. And then I should go over at least one quick tutorial on IDA.
We get to choose our own adventure?
Sure. If you have a topic of x86 you wish to want me to discuss, definitely tell me. But next comes good old miscellaneous. That is a knee slapper there. So if you got questions, please ask. If you browse the web, you may forget what I'm saying. I am the benevolent dictator, the end. And it's called x86 because of the progression of Intel chips from the 8086, the 8186, the 8286, the 8386, the 80. Okay, I think you get the idea. What we're going to learn first. Whew. Everyone going to be okay with this?
Oh no. Hello world.
It's difficult.
I know. Well, hang on.
So complicated.
Yes. Well, I mean, it really looks like that. Right?
It's more like it.
Of course, that's in Visual Studio 2005 with buffer overflow protection turned off and disassembled with IDA Pro version 4.9, the free edition. Sweet. GCC does this with good old obj dump. And Mac does something like this.
What is called?
What's what?
Why does call have 3 L's? That's a call.
Because it's a super call. This call, oh, this call only has 2. Oh, because it's Mac. That's a great answer.
Yeah.
Oh, it's the long call. It's call. No, that is what it is. I'm not kidding. I'm not making that up. I'm not making that up. Not making that up. Because it's add L, the long add. Okay. But it really comes down to this. You want to push some offset of hello world, call printf, pop the return so you can ignore it, set up the return for our main function to 1, 2, 3, 4 hex, and then get out. That's really what our program does in assembly. By the way, for those of you who can't read this, I need like a giant stick so I can go whack, but I can't do it. The .text section, if you remember from previously, is where you store your instructions. These are the memory addresses of where your instructions are stored in the program that it's running. That's a label, because notice that the label and the first instruction have the same address. So the push instruction is this 401 blah 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 5. Hey look, the next one's at 5. What does that mean about the push instruction? That it's 5 bytes long. The call instruction is from 5 to B, which is, what's B? That's 11 minus 5, that's 6 bytes long. Notice that the move instruction, or actually the pop EAX, that's 1 byte long because it went from B to C. Oh, look at that. Silly x86 and its variable length byte coding. Aren't you glad you don't have to do that in Verilog? The answer is yes. Trust me. And then you have move, which looks like it's, what is that? DEF 01. That's 5 bytes. Wow. Oh, because it has a immediate field. Cool. So go ahead and take heart. There's only 14 assembly instructions, which account for 90% of all the code in x86. So we don't need to learn the, I wonder, there might be 1,000 instructions by now. I wouldn't be surprised. But there's a lot. It ends up being that if you know about 20 to 30, not counting variations, so 20 to 30 general instructions, and once you get the hang of it, you'll understand what I mean by that. That you'll probably be good enough to at least get your feet wet, and if you really are a pro, you can delve into this deeper. If not, with these 20 or 30, you'll always have a general idea of what the assembly is doing. We've already seen 11, even though we didn't talk about them at all. I just threw them up there and y'all memorized them perfectly. So we'll get going. But before we do that, and before we conclude, which will happen soon, one quick refresher on data types. So in C, a character is 1 byte. Now, very important, other languages have a character be more than 1 byte, namely 2 bytes, and I've seen some languages make a character be 4 bytes. But anyways, in C, which is what we're going to deal with because all other languages are way too complicated, it'll be 1 byte. A short is 2 bytes. An int long, or a 32-bit long, which is really 4 bytes, that's what it is. And then the next one's called a double, or a long, or a long outside of a 64 is 64 bytes. And then I guess a long double is 128 bytes? Sure, why not? So let's see, radices, is that how you say radices? Is that the word? Is that how you pronounce that? How do you pronounce that?
Radices.
Good. Decimal, binary, and hexadecimal. If you don't know this, you must memorize it tonight. Good, because on Friday, I won't grill you. Oh well. So there's the binary. The idea is that in hex, you can do 0x, and then this is the hexadecimal digit. It goes from 0 to F. Hopefully everyone's familiar with that. Here's the binary version. Ends with a B. That's the same thing, but with 1 zeros. And of course the decimal's over there. This look at least familiar? Please try and memorize this because it's going to help you immensely. Just this table right here, knowing what it goes up to F. Yeah.
We gotta memorize hex value.
Yes, 0 to F.
Neat.
Otherwise, you're going to have trouble. Yes.
So what if we just make that our desktop background?
That'll be great. Especially if like superimpose my face behind it staring at you.
Don't want to break the screen.
Wow, that was a little rough there, Holland.
That's some bullying.
That's some bullying.
Sam, after what you said already?
All right, so 1's complement, and we talked about 2's complement, so we actually don't need to go over this. This is kind of a more confusing way of just explaining what we did earlier, but notice, keep in mind that hex FF is -1, hex FC is -4, E6 is still -26, because those front, just think about what that leading 1 bit is, and for that hex, spoiler alert, if it's 8 to F, that first bit's gonna be on. All right, I think we're gonna go ahead and pause. Oh yeah, CISC versus RISC, that'll be a good one to start off with. Yeah. All right, take that out.